So we're on to principle number 8. We're talking about nonlinearity and chaos. So nonlinearity can be understood in a number of different ways, and describes a relationship where there's a no direct connection between two variables, but instead change can only be described through looking at multiple indirect connections or feedback dynamics. So the core of it is saying there is no direct connection. There isn't linear correlation or causation between this thing and that thing, or these two things and that thing. We have to actually think that this thing here is not a product of a linear interaction, but instead it may be the product of multiple factors affecting it in a nonlinear networked fashion. And that's kind of a paradigm shift, goes this idea of emergence that we're talking about here, that actually the phenomena is emerging out of multiple interactions, multiple factors, instead of the product of a linear cause and effect of a few variables. Nonlinearity allows for the output of an interaction to be less or more than the sum of the parts in isolation, making nonlinear systems non-additive. Nonlinearity is the product of the synergies between the parts that makes the combined effort from the parts, which is different from the combined effort of the parts. So when you put two things together, they're non-additive when they don't add up. 1 + 1 = 2. Put them together, get synergies, you get the emergence of 3 or 4 or something like this, and that we would describe as non-linear. We put all this set of factors together around here, and suddenly we get the emergence of something more than them simply combined in an additive fashion. Due to specific interaction within a drug concoction, for example, I mentioned this before, the combined effect of the drugs will be different from each taken in separation. And that's an example of a nonlinear emergent phenomena. Because of the feedback loops between the parts, the output of a nonlinear system may be disproportionate to the input, and it can grow or decay at an exponential fashion. So nonlinear systems are known that when you create an input, the output is not proportional to that, not necessarily proportional. In a linear system, there's this cause and effect dynamic where this thing will cause this thing, and the more you affect this, the more you'll affect this. There's that proportionality between it. In a nonlinear system, because there's many factors, many variables, and you get emergence, you can input something and you don't know what the output will be. Sometimes it'll be radically greater than you think, sometimes not, because there's feedback loops going on. In a financial crisis, you might have, just one small bank collapse, but that could actually have significant systemic, massive outputs, because there could be these feedback loops in the system, but that one event is driving a positive feedback loop that's amplifying across the system as other banks get into distress and depositors take their money out, and that drives insecurity and lack of trust in the system, and so on and so forth. That amplifies itself so that traders don't want to trade, banks don't want to exchange, people want to take their money out, so on and so forth. And ultimately, the output to that system could be radically disproportionate from the input. That's part of what we mean by nonlinearity, quite a broad concept, and has different facets to it because it's understood in different areas of maths and physics and so on. But generally, we're talking about the idea that there is no linear relationship between two things. There is no additive. You can't just add them up to get the whole. And there's no linear causation in terms of this thing is caused by this thing. And if I affect this, I will get an effect out here. This will cause this to change in a proportional way to that. That's a linear system. Nonlinear system, multiple factors affecting this outcome. And we're getting the emergence of non-additive outcomes from all those interacting variables that can make the input different from the output. So it's nonlinearity. We can see it here. We're often thinking in a linear way, search for a few causes to a problem. That's linear thinking. On the right, we're asking, how does this phenomena emerge out of many different factors in a nonlinear networked fashion? And it has this disproportionality. It's not additive nonlinear systems, we get exponential change. And that's getting into the idea of chaos theory and so on that we won't go into right now, but that's nonlinear systems. Hopefully you grasp the concept of trying to shift from a linear way of looking at the world to a nonlinear way of looking at the world. Absolutely key to being a systems thinker, to understanding complexity. Complex systems are inherently nonlinear. And it's a key idea to understanding emergence because of this idea of 1 + 1 equaling more or less than 2. So we're getting the emergence of something that's different from the sum of the parts.